let's discuss for a moment some basics of circles. Okay, now let's pretend that what you're looking at right here is an actual perfect circle. It's kind of hard to sketch freehand, so you're going to have to use your imagination. Now, there are certain parts of circles that we use all the time, so we need to understand those. And then there's some other ones we'll get into later in the year that are a little less useful. And they're useful in their own way, but they aren't as common, we'll put it that way. First thing we want to define is all the way across the circle at any point, but it has to pass through the middle of the circle. Anytime we cross all the way through the circle, we call that the diameter. Well, that's not coming out too good, so let's do this. Okay. We will just write that down here. Okay, so the distance all the way across the circle that goes through the middle is the diameter. Now, it doesn't have to be like that. I could have a diameter that goes right there, as long as it still passes through the middle. Okay, and once again, use your best imagination here. Pretend that went through the middle as best you can. Okay. Now, there's something else we need to recognize. Anytime we have half of the diameter, so if we were to go from the center out to one edge anywhere, okay, half the diameter is called the radius. Okay, and they're always in that relationship, meaning if you know the diameter, the radius is exactly half of that. Okay, so I'll put a little r here to mean radius. Now, what if you had a whole bunch of lines in a circle? Let's see how we would interpret that. What if we had something that looked like this? Okay, and let's say we had some angle measurements here. Let's say this was 45. This was 50. Okay, and you're asked to find some of these other numbers. Okay, now, let's just think about how we might be able to do this, because you've done a lot of work with lines. Now we have lines within circles, but that doesn't change the properties of the lines. The lines are still lines. It doesn't matter that they're inside of a circle. So if we go back to like first semester, quite a while ago, we talked about how if you have angles that are opposite each other, that come from two crossing lines, those are called vertical angles. So if I've got 50 degrees over on this side, then this side must be 50 also. Now, could I say that since this is 45, does that mean that that's 45? And if you look at that and say, that just doesn't seem right, well, that would be correct. Okay, there's a lot of ways to approach this, but you can just look at most drawings and tell if it's close or not. So how do we figure out some of these other angles? Well, let's think about our other properties here. What about, oh, that's the wrong one. I have to actually draw this. What about, so let's put this back in there. What would you say if we had one straight line? How many degrees is a single straight line? Okay, and a straight line, we always said, is 180 degrees. Just like when you're trying to dunk a basketball or do a jump off a snowboard, if you turn halfway around, it's a 180. Turn all the way around, it's a 360. Now, if we use that concept, that means all the way from one side to the other in degrees is going to be 180. It's a 180 degree turn. Now, if I already know that I have 50 and 45, I can add those together to get 95. And what's missing from my other piece over there? Basically, I can take 180 minus 95, and I get 85. So this over here is 85. Now I know in my drawing it doesn't look like that. 85 all of a sudden looks smaller than the 50, but this drawing is not to scale. This is just a sketch, and sometimes when you sketch things it doesn't come out proportional like you think it should. Okay, so the numbers say that would have to be 85. Okay, now what about over here? Okay, let's say we want to find this angle right there. Okay, let's think about where we have some straight lines. In fact, we've got a straight line right there. So that's 180. And I already know 50 is right there. So if I take 180 and subtract 50, I'm going to get 130. So this space is 130 degrees. Now for every circle, if I add all of these things up, all the way around, what should I get? Well, let's go back to dunking a basketball or jumping off a snowboard. If you spin all the way around one time, what do we call that? We call that a 360. And if I add all those up, I should get 360 degrees.